My name is Hiroki Okui, and I'm a member of Technical Development Department of Entity Communications, and I'm a software research engineer and in charge of transport SDN technologies. And now I'm contributing to the ODTN project. And recently, I made a challenge to integrate Whitebox Transponder Cassini with ODTN controller and collaborating with IP Infusion guys and the NTT Electronics guys to make this work successful. So today I'd like to, as Andrea mentioned about this topic and gave a brief introduction, so I'd like to give you the a little bit deep and detailed topics about this kind of things, and about the overview of the Cassini box and its technologies, and how to the detail of how to integrate the Cassini box with ODTN. This one, yeah. Okay, so let me get started from the recap of the concept of disaggregated transport network. And you know, now we're in the left side, and all components of the ROADM are aggregated and provided from the single vendor. And these components have a proprietary and closed API and vendor-specific data models, so that we have to use vendor proprietary network controller, and it is difficult to change to the open source network controller because the northbound interface and the models are different by vendors and devices. And what we are going is right side, and all components in the ROADM are fully disaggregated, and each component has open standard API and the common data models, so that in addition to avoiding vendor lock-in, we can do software integration of these disaggregated components much easier than the legacy or one-type ROADM system. And this is a reference design of ODTN. And the ODTN controller is supposed to configure the multi-vendor open config devices. And currently in the phase of 1.5, we also, the ODTN controller is supposed to configure also offline system. And ODTN controller is designed to install the transport network of the metal domain and the data center and the interconnect network. And to achieve this kind of open transport network controller, which can configure the multi-vendor devices, we need to use open APIs, and we decided to use transport API and OpenConfig. And you know, as a northbound interface, we select transport API and over RESTconf, and as a southbound interface, we select OpenConfig for configuration of transponders over netconf, and also transport API over RESTconf. And you know, open-line system is one of the style of optical disaggregation, and which is called also partial disaggregation. And in the open-line system, we can select multi-vendor transponders in a single line system, but all components in the line system should be provided from a single vendor. And the open-line system, as Dominic said, I mentioned this topic, but open-line system is much practical approach compared to the fully disaggregated approach, because on the one hand, we all components of the line system are provided from a single vendor, so that we can use the line system controller from the same vendor. and it reduces complexity of the software integration of the line system, because we can delegate some optical management some complex optical management features like power control and power simulation to the line system controller of the vendor property controller. And on the other hand, we can select preferred vendor's transponder for each lambda of the same WDM system. So the OpenLine system gives us both flexibility and easy integration. So now we're heading to this direction in the ODTN phase 1.5. And as I mentioned, in the ODTN project, there are 3 implementation phases. And for the first phase, we focused on the provision only transponders in P2P topology, and the scope of the configurations are limited to port enable and disable and cross connection between the lines and the client side. And we didn't configure any optical media layer parameters because the optical media parameters should be dealt with OpenLine system after the next phases. And in this first phase, we successfully integrated with multi-vendor. It's actually multi-vendor transponders from Infinera, NEC, and Nokia. It's different. And then now ODTN CHIM is in the phase 1 to 5 and trying to integrate both transponder and OpenLine systems. But at the same time, we NTT-Com and IP Infusion guys trying to integrate Whitebox Transponder Cassini with ODTN, and finally we completed this work successfully and provided demonstration at the ONF Connect booth. So I'd like to share the detail about that today. Is it different slides? Yeah. Yeah. And sorry, I skipped this slide. And Cassini is a Whitebox transponder, developed by HCore and TIP. And HCore contributed its hardware, and it includes Broadcom Tomahawk ASIC, and which offers 3.2 Tbps throughput, and also it provides for the line side, for the client side, it provides 16 ports with 100 Gbps QSP2.8, and also for the line side, it provides 8 ports with 200 Gbps CFP to ACO port. And NTT Electronics helped to develop the optical coherent line cards, and and they also provide the CFP to ACO module to the Cassini box, as well as any other optical companies like KG, Okura, and Finistar, and so on. And in the Cassini box and DSP chip, transport abstraction interface is used. And transport abstraction interface is offered by Telecom Infra project, and it's called TIE. And TIE is abstraction interface between optical transponder and its system software. And it decouples the transponder hardware and its network operating system. And it achieves the software and hardware disaggregation. And so we can select preferred vendor transponder hardware and preferred network operating system separately. And this gives us flexibility and agility to transponder development. But it is not designed as northbound API, and is not useful from the northbound SDN control perspective. So and TIE achieves the software and the hardware disaggregation, and it enables us to change from the right side aggregated way to the left side disaggregated way to develop transponder. But from the northbound perspective, we need additional interface and the YANG model to configure this kind of TIE-based Whitebox transponder effectively. And in the ODTN reference design, we want to use OpenConfig as a northbound interface of transponder. So it is desired that this application, the top of double Cassini box applications expose its configuration and the state to the northbound SN controller and using OpenConfig API. And to achieve such kind of OpenConfig API, we collaborate with IP Infusion, and which provides network operating system, which is called ONOS. And thanks to their active contribution, finally we successfully integrate ODTN and Cassini boxes with using all open APIs, TIE, and Transport API, and OpenConfig and TIE. So let's move to the implementation detail about the test result. And as I mentioned before, Cassini has Cassini has 16 client side 100 gigaports and data line side 200 gigaports, and so it can be represented as kind of this figure using Transponder API model, and two nodes are connected with this. Two nodes are represented this kind, like this, and each node has it is missed, but each node has 16 service interface points to expose to the northbound user application as an end-to-end connection of the request point from the northbound interface. And also, it can be represented using OpenConfig, like the upper side and upper model, and the client side port and line side port are described as a transceiver using OpenConfig and OpenConfig platform YARN model, and also the cross connection between line side port and the client side port can be represented using can be described as the logical channel using OpenConfig and terminal device YARN model. And the mapping between Transport API and OpenConfig is quite simple. And in the Transport API representation, and the connection endpoints are created for both connection and this green line, and as an endpoint of these connections, this green rectangle. And so all we have to do is to find each endpoint, each connection endpoint. All we have to do is to find each connection endpoint are associated with what port of the actual Cassini box port, and find the actual device port associated with these connection endpoints. And in this example, this first connection endpoint is for client side and is mapped to the OpenConfig logical channel, the right side. And the second connection endpoint is for line side of the connection and is mapped to the OpenConfig logical channel. And the OpenConfig logical channel assignment is represented like this, and using OpenConfig logical channels. So and that all for the mapping between TAPI model and the OpenConfig model. And also you might Okay. Also, you might know the ODTN application is based on dynamic configuration subsystem, and dynamic. So let me give a short introduction about the dynamic configuration subsystem. And you know that dynamic configuration subsystem is a model-driven controller which supports net configuration subsystem, and dynamic configuration subsystem is launched in 2016 and released last year. And the dynamic configuration is designed to provide netconfig YARN based network configuration features along with the OpenFlow and P4 based configuration features, control features. Sorry. And DCS consists of ONOS YARN compiler and runtime and the distributed config store, and also dynamic configuration subsystem itself. And when we provide TAPI YARN model and the OpenConfig YARN model, and dynamic configuration subsystem automatically generates the northbound RESTconf API and also the southbound OpenConfig based driver, and also ONOS YARN to generate the distributed config store of the OpenConfig and the transport API to process the service request from the northbound the user application, and the device configuration of the OpenConfig, which should be stored in the each network device element. And using this kind of automatically generated components, we ODTN team expected that all we have to do is to implement this orange box, and all we have to do is to implement ODTN specific core application logic. And also we expected that any other basic application features are ODTN can delegate to the dynamic config subsystem about the or any other basic features. That's the short introduction of the dynamic config subsystem. And okay, as a test result, and finally we made ODTN and Cassini box work together properly and provided them as a venue successfully. And to be honest, we have only 2 weeks to implement the driver of the Cassini box and integrate them, but we completed it in time, even though it seemed a long way to do that because we use only open APIs like TAPI and OpenConfig and TIE. But finally we succeeded that, so we got the confidence that the Cassini, and it is not so hard to integrate Cassini and ONOS with ODTN and their promising devices and the network operation system as a transport Whitebox. But as of now, both DSP chip of the Cassini and the ONOS are not matured and still work in progress, and and so they are trying to implement missing features to support full capability of the transport abstraction interface and expose other parameters like optical media layer to the northbound interface and the northbound SDN controller. And I think so we'll have a good experience with Cassini in the next year, and we'll give a good report to you in the next conference, next ONF Connect. And regarding the dynamic computation service system, we found that there's some critical issues inside it, and we need to implement some additional features to avoid the dynamic configuration limitation. And also, unfortunately, some of these issues are derived from its architecture or its basic design, so we need to address in order to so I'm sorry, it is needed to address from dynamic configuration basic design to address these issues, so that we are considering to now implementing dynamic configuration subsystem 2.0. And I think the lessons learned we ODTN change lessons learned from ODTN implementation will be a good requirement for the next dynamic configuration 2.0. And as takeaways, we trying to use Whitebox transponder for disaggregate transport network and integrating with ODTN. And this challenge was succeeded, even though we have a short time to do that. So we think ODTN and Cassini is a good starting point to realize Whitebox and transponder and the controller. So, and if you're interested in our activities, please come and join us. Thank you.